So for those of you who are interested in getting a newer tool chain on CentOS, this is pretty much what we got. CentOS and RHEL have a tool set called Developer Toolset, which is to help everybody get some of the newer tooling in place, because for those of you who use CentOS or are aware, the default compiler for the system is GCC 4.8. Whatever, it's usually 4.8.5 or something along those lines. And so the common complaint that we hear is GCC and a lot of the tooling around it is just stone old. And there are a fair amount of improvements, as you all know, for ARM64 on newer versions of the tools. Marcin!
Yes, it's me!
And you didn't bring me any grapes. I will steal them from you later.
Good.
All right, fine. I'll take that one. So the way that we go about getting new tooling on the distribution and maintaining compatibility with what we've got is the developer toolset. The developer toolset basically allows us to have newer bin utils, newer GCC, some O profile updates, strace, a lot of the various things you'd expect to have to build tools, help you get better debug information. There's a newer Perl and a newer Python in there as well. A few added bits in there to help speed things along. But you guys are probably more interested in how it works than what's in it, so we'll get to that. The basic part of it is the same thing as everything else on CentOS. It's a yum up or a yum install. So, wow, I need to work on better font for this, or brighter font for this. It's essentially a yum install dev toolset 6 is the command that gets you everything that you need. And once it's installed, it'll go through and do some. I didn't do live demo for this. I didn't trust the network enough, so I took screen caps. We probably could do live demo. The network seems like it's holding up reasonably well. But if you look at what GCC is after you do the install, it's still 4.8. It's still the base default GCC. So once you've got it installed, you need to enable it. And there's a really easy way to do that. And that's essentially to do SCL, which is software collection, enable DevToolset 6, and the command that you want to run. So DevToolset is a per instance type of command. So for the first time that you run it, or for the first shell where you run it, you'll get GCC 6. If someone else logs into the machine and they want to do a bog standard build, they'll get GCC 4.8. Whatever, unless they enable it as well. There are ways that you can enable it globally. We want to give folks the option for, do I use the newer tool set, do I use the older tool set? So this is how we do it. And as you can see in the second line, if you can read the really dark font that I will improve for the next time, the GCC path actually changes. You go from user bin GCC into opt Red Hat dev toolset 6 root user bin GCC. It is per session. So each session you will need to enable it, or you can cheat. And you can do a source and then the file path in your bash profile or whatever, and then it's just every time your bash profile gets, or your bash RC gets sourced, then it runs through that and you will just always have it from that point on. So what this actually does behind the scenes, and that source file that I was talking about, is it exports a whole bunch of paths and it overloads your primary path. So it puts the new version of GCC in front, updates the man, updates some of the library pathing, puts some additional Perl pathing in there, updates the LD library path, blah, blah, blah. So this is why everything is basically per session, because it does this. So as soon as you exit out of that bash shell, all of these go away, because the parent process is no longer there. So this basically gets you to a point where you can run GCC on the command. You can do your make, you can do whatever for here. But if you're looking at building packages, then it gets a little more interesting. So if you're doing RPM builds, and I would encourage folks on RPM-based distributions to do RPM builds, if you're on Debian-based distribution, do deb builds. I have a whole different soapbox that I get on about actually doing proper packaging. It's essentially a 3-line fix. There, in this example, I'm using the CentOS kernel for what we do. So I increment the first line. There's a cent update bump just because I want it to be a new package, so it'll be installed the next time I run yum. The second line is a build requires that adds in DevToolset 6 and DevToolset 6-build, and that's basically what you need to run GCC and what you need to build against software collections. Technically, you don't really need the last one, but it's always helpful just to have it there when you're doing builds. And the last bit, the very bottom line, is sourcing that enable file so that the RPM build environment can pull that in and build against it. So since we're already using the kernel spec file, we use the kernel as an example. On a base standard CentOS system, you can see here that it's the kernel's 4.5.0-20, and I picked the kernel specifically because it always shows you the build line in proc version, so it's really easy to see what version of GCC it was built against. Some other binaries, when you build them, the header information gets stripped out, and so it's a little more difficult to tell. So here you see it's built against 485. On my box, I run the update. It throws the new kernel packages in there. You can see the line where it says that it updated. It's now the -23. I added a bit of additional information so that I can tell that it's been built against GCC 6. And you look at the cat proc version again, and you can see. Do I have the? Where's the? Oh, there's a pointer. You can see GCC 6.2.1 is how it's been built. So it's really just that simple for CentOS. There isn't a whole lot of information for doing it other than that. It's a yum install, a source file or software collection enable the collection that you want to enable, the command, and that's pretty much it. The rest of it is down to build changes or language options that are different in the versions of GCC. So you may run into compile errors for something that built against an older version of GCC that is now a little more strict or a little more pedantic in newer versions of GCC. So, questions? Yes. We have Python 3, we've got newer versions of PHP, we've got a lot of different new software collection toolings available, but the one that we heard the most from a lot of the folks around here was we want GCC 6, we want to be able to build new things against GCC 6. And so starting off with the kernel seemed like kind of an easy way to show, hey look, yes we can do this, this is what happens. And to be fair, the box does seem to, perk up just a little bit when the kernel's built against a more modern compiler. So, I didn't do any numbers testing on that one. I didn't have time at the point where I was doing this, but it does feel like it moves a little quicker. You could, however, if you do that, you risk breaking ABI stability for a number of other things. glibc is core enough to the system that if you built against a newer GCC and dropped the newer glibc on the system, third-party packages that were built against the standard CentOS libraries or RELSA libraries may not install or may not operate as you would expect. Some libraries you can do that with, some libraries can't. We're playing around with them now, mostly to find out how we can maintain a stable layer but still build against newer tool set to give people more performance or newer hardware options that have been added in the later GCCs. So, right. So if you built the exact same version of glibc with the newer compiler, you could probably get away with it. But at that point, why? Right. You wouldn't get a lot of the improvements that have been put into glibc since the version that's on the distribution. Replacing the system glibc with a newer glibc that's been built against the newer tool chain would result in basically a Franken distro that would work fine for you, for your use case, as long as you built it, but anytime anybody pushed an update, it would break. At that point you could, but then Marcin's point rings home. That's a perfect use case for a container, and you know, at that point we need to look at what you're doing. If you wanted to do it, you could, but glibc gets really weird about pathing and everything else. There's a lot of expectation around it because it is kind of fundamental. Uh-huh. Mm-hmm. If you had an unbounded call that went through that glibc that was just, you know, a malloc or whatever without being namespaced into your particular thing, the system would get really confused as to which one it was trying to use and what was going on. So that's a good question. If I want to say let me, there we go. So 312. Or if there were other packages in there that you wanted to, you know, ask questions about, that's basically the list. There are, I want to say roughly 30 packages that make up dev toolset, and then you were asking about stuff outside of that. All right, I guess I need to check the status of that mirror then, but there are a number of other software collections that have stuff available. Not everything that was here, or not everything that was in this directory was built for ARM64. The older dev tool sets don't build against 64-bit ARM architecture, so 3, 4, or 3 and 4 won't be there. Some of the other tooling is hit or miss, but the Python is there. The other option for Python, if you wanted a newer one, is Fedora's EPEL library. The extra packages for Enterprise Linux, they have a Python, I want to say 3.4 or 3.5, that's been pushed. For folks who don't know, the Fedora project has another library or another repository of packages that works very closely with CentOS. The board for this particular repository is, I want to say 5 seats, and 4 of them are CentOS members. I think there's only one Fedora person left on the board that makes it up. But there are a number of extra packages in there as well that help move things along. There's a cross-compiler tool set that's in there. Any package that you would have for x86-64 on or from the EPEL package or EPEL repository is there for ARM as well. So we've got the full suite. Other questions? All right. Thank you very much.